Video answer key. We're going to go through questions 5, 6, 7, and 8. These are the application problems or story problems, so I'm going to go ahead and quickly set them up. For the sake of the video, I'm going to forego marking up each one of the lines just to make it quicker so you guys can get to the meat of it quicker. Here we go. All right, so first question 5. Janet has a 14-foot ladder. The safety instructions recommend that the base of the ladder is placed 3 feet away from the base of the wall. How high will the ladder reach up the wall? So in this case, the ladder will be the hypotenuse. So I'm going to make a triangle, right triangle. My house is over here. Yay, there's a little building. Woo! Awesome right there. Artwork, you guys love that artwork. I know you do. Okay, so there's that. This is a right angle, provided the ground's flat. Let's assume it is. The ladder is 14 feet tall. Sorry, 14 feet long. It's not tall. And then the ladder has to be 3 feet away from the building. So we're going to go ahead and label the missing side A or B. I'll just go ahead and use B. All right. So the biggest mistake students make with the ladder problems is they often put the ladder as the leg instead of the hypotenuse. So if you avoid that mistake, chances are you'll get this question right. Okay, let's go ahead and set it up. So in this case, it would be 3 squared plus B squared equals 14 squared. Okay. 9 plus B squared equals 190. 14 squared is 196. So we have 196 here. We're going to subtract 9th on both sides. 196 minus 9 equals 187. So we're going to square root both sides. Square root of 187 is going to be a little bit less than 16. Let's find out what that is. It's going to be, oh, sorry, a little bit less than 14. My bad. B is approximately 13 and 7 tenths. And we'll just say 13 and 7 tenths feet. Since there's a unit in there, make sure you include it. All right, next question. All right, Roscoe, our buddy Roscoe goes for a walk in the field next to his house. He walks 1 kilometer north and then turns due east. So he's going to go 1 kilometer north and he's going to turn due east and go 3 kilometers that way. Okay, he decides he is tired and walks directly back to where he started. So he started here and he's going to walk directly back to that location. So we have our good old right triangle again. Okay, the one leg going north was 1, and this leg is 3, and we're trying to find C. So I'm going to do the math over here. 1 squared plus 3 squared equals C squared. So we have 1 plus 9 equals C squared. 10 equals C squared. Square root of 10 is going to be a little bit more than 3. Let's figure that out exactly. It's going to be, we'll call that 3.2. It's about 3.2. Let's round it to the 10th per the instructions. Okay, now that's actually great, but the question's asking what is the total distance of Roscoe's walk? So we need to go ahead now and add these together. Plus 1 plus 3 and 2 tenths. Nothing here, so we have our 2 tenths. Add those together, we have 7. So the walk is 7, approximately 7.2, in this case, kilometers. Why? Because the metric system makes sense. Yep, biased. All right, question 7. Dell believes the numbers 210, 280, and 350 are side lengths of a right triangle. Do you agree or disagree? Use words and or numbers to show how you determine your answer. Okay, the easiest way to do this is to recognize that if it is a right triangle, that will have to be the hypotenuse, so set it up as such. So 210 squared plus 280 squared equals 350 squared. Technically, we could divide all those by 10 and simplify the math, but so 210 squared is 44,100. 280 squared is 78,400, and 350 squared is 122,500. Okay, now the sum of the values on the left side of the equation are indeed that same value. So if these equal each other, right, it satisfies the conditions for a right triangle, so I could say yes. And then point over here to C math, Mr. Teacher. That'd be me, I guess. All right. This last one's a classic Pythagorean theorem in three-dimension problem. So Rachel is mailing her friend a map of the Shire. She has a box that measures 52 inches by 3 inches by 4 inches. What is the maximum length the map can be to fit in the box? So I'm going to sketch our box real quick. So the box is 52 long. It goes back 3, and then its height is 4. So here's my quick sketch of my box. I'm going to put the Shire map in. Please don't worry about these being to scale. It doesn't really matter. It's kind of the back. We can't see that. And that's kind of, we can't see that either. So we have 52 here. We have 3 here. And we have 4 there. Now I'm trying to determine the distance from this end to that, and not my best drawing ever, but we're going to go with it. So that's my D. So in this case, the diagonal is going to be, it's going to be D squared equals, well, you guys know it in your notes, it's actually shown a different way, so I'm going to rework it. So we have 52 squared plus 3 squared plus 4 squared equals D squared, or unknown diagonal length. So 52 squared is 2,704 plus 9 plus 16. The sum of those 3 values is 2,729. The square root of that value is 52 and 2/10. So 52.2 equals D. So we could say the maximum length, max is 52.2 inches, or 2/10 inch. Okay, so I actually rounded that down, which if you were in a couple of my classes, we talked about how you almost always have to round that number down. In terms of your map, your test, though, guys, if you round it to the appropriate decimal, I'm not going to say it's wrong. So, yeah, in this case, 52 and 2/10 would be the correct answer either way. All right, there's this one. I hope it was helpful. Yeah, deuces.